Welcome everyone to Knox Game Design for March 2026. My name is Levi Smith. This month I'm going to be talking about N64 development. So a little bit of background about the N64. The N64 wasn't the first console that I owned, but it was the first one that I bought myself. I didn't have to ask for Christmas or a birthday. I think I was probably late teen, came out in the late 90s, around 1997. So this is a little bit about the architecture. It used a CPU called the VR4300 CPU. It was a modified NEC VR4300. It has a FPU, floating point unit processor, COP1. It also had a reality coprocessor with the reality signal processor, reality display processor. And you can see these on the motherboard picture right here, the VR3400, the reality coprocessor. And here's the two DRAM. It had Rambus DRAM 4 megabytes. It had a chip called the PIF NUS based on Sharp's SM5 microcontroller, and it also had an audio and video DAC, and DAC is digital to analog converter, and you can see those here on the side. So that's just a little bit of the background about the architecture. So this month I kind of got into learning how to actually develop a game, very simple game, for the N64, something I've never done before. I've developed an NES game before, but not for the N64, which is pretty cool because I was able to actually deploy it on real N64 hardware, which I will show at the end of the presentation. So the development environment that we're using, I'm using a new tool that just came out called Pyrite64, which is pretty neat. I believe it's still in development. So it's a game development environment for the N64. It's like Unity or Godot, which is pretty nice. You can only use it with authentic emulators. I'll talk about that in a little bit. You can actually run your game builds on real N64 hardware, which I actually did verify at the end. So you can download this software from either SourceForge or GitHub, and there's also Windows builds and Linux builds. So I did it on Windows. Yeah, I know. So this Pyrite64, you download and extract the zip. You run Pyrite64, then it comes up with this little setup process. So first thing you got to do is install MSys2. So I actually already had MSys2 on my Windows system, but I had it installed on my D drive. It does not like that, so I had to install another MSys2 on the C drive. And here's a little picture of it right here, installing everything. All you have to do is press install to install the toolchain. I'm not going to show this. I got the screenshots. After you get everything installed, they should have all green checks right there. So it installs everything that you need in MSys2. There's a library called libdragon, another one called Tiny3D. So it sets all that up for you, which is pretty nice. So once you get all this installed, you can bring it up and set up a simple project. Just select create new project and select the project folder. So that's what it looks like over here. And I will show that right now. So here's Pyrite64, and you can create a new project. I already have one created in my first simple project. I have it, and I'll have all this code in a source code repository. I just have this called Project 01, Knox Game Design, first project, P64. Open that. So yeah, it looks a lot like Unity. If you're familiar with Unity, the movement around the game world's the same. It kind of just gives you a simple project right here with just a box. So what I did is I just created a new box. You can go up here, go to your scene and add object. And then you can see here's my first object. It's a lot just like Unity. You got a position, scale, rotate with the different values for those. And you got a model that you can pull in here. It uses GLB format, which you can create in Blender, which is pretty nice. So I finally got it working where you can actually run this. First thing you got to make sure is in settings. You can only use like certain emulators I mentioned, so it likes Ares. So you can just go in here and select the Ares emulator. Right, I already have that installed, extracted. So you can also, I'll have links to install all this stuff. You can either use Ares or Gopher64. Gopher64 was the first one that I tried that worked, but Ares is, I think it really likes you to use Ares. So you can just go up here and press build and run like that, and you can see here it's building everything out. And yeah, all the code is in C++ if you're using Pyright64. And here's our N64 game right here. It doesn't do anything, but it proves that we can actually create an N64 ROM. It's in the Z64 format. It doesn't do anything, but we added an object and we got it to render, which is actually pretty cool, like first N64 game. Yeah, so here's some notes that I made about the editor. You can hold right mouse and WASD, like Doom movement to move around, just like in Unity and everything else. You can right click, yeah, I already mentioned that, add a component, add your model, and select the GLB file right there. So I already talked about that. Create and build, I already talked about it. Build and run, wants to use Ares as the emulator. I already talked about this. Go into settings, emulator, so it starts automatically, which is pretty nice. When I first started this, I was having to run it externally, which is kind of a pain. It creates a Z64 file and run with Gopher or Ares. So the next thing I did after I just made a simple project, so this is the guy that created this great editor, Pyright64, but they have game jams, specifically in 64 game jam. So this guy created a test project, which is actually really good. So after I got my test project running, I just tried to open this simple project right here. So I'm going to go open a project and then go into the extracted Pyright folder in 64 examples, jam 25. I think this was like a 2 or 3 months jam, so it wasn't like 48 hours or anything. It would be really impressive if they did this in 48 hours. But this is the way I learn, looking at other people's projects and kind of changing stuff, seeing what works. So yeah, if it comes up like this, you just got to click map intro like that. And then you can see this game world right here. So I think it has like 2 levels. There's a skybox over here in the background. You can see that. But you play this little TV guy. See if I can build this out, build and run. Okay, so here's one thing to look out for if it says Ares is not recognized as an internal or external command. So you have to set up Ares on every single project, unless you might be able to put it in your path. But let's go ahead and do that. So I have Ares right here, extracted out. And like I said, this is all under Windows. So Ares load, I might have it under recent. But let's go ahead and do Nintendo 64, and then go to our demo project, as in the Pyright, N64, examples, jam. So here's the Z64 file that was generated, 327. That's when I'm recording this. So just double click that. And it's a pretty impressive game. Yeah, so the guy's name is Max Bebach. I'm not sure if I'm pronouncing that correctly. Turning the sound down a little bit. So the intro is kind of slow. So you got this guy, he asks you a lot of questions. It's kind of reminds me of Banjo-Kazooie. Let's see here. Yes, make sure you press OK. If you select default, it just goes into an infinite loop. So you can hear the sound effects from Banjo-Kazooie, and it does kind of same zoom in or black out. And yeah, you got the little, it's kind of like the musical note blocks, and I am using a PlayStation controller, but I got everything mapped to, like the C buttons are mapped to the right joystick. So you collect these little guys and you kind of like unlock the doors right here. 10, that one unlocks right there. So you kind of got like, yeah, these little rotating blocks right here, platforms you can jump on. There's 25, and if you touch these guys, you get damaged. So yeah, it's a pretty impressive game right here, made in Pyright64. Yeah, so the next thing I wanted to do is see if I could pull in a Blender model into my N64 game, see if that was possible, see how difficult that would be to do. So I got it working, and I kind of outlined all the steps to create your model in Blender. There's a lot of restrictions on what you need to do, but the first thing that I ran into is you got to have this Fast64 add-on enabled in Blender. If you don't have that working, it's not going to work. So you can get that from GitHub, Fast64. Then you go into Blender, edit preferences, add-ons, install from disk, then select the Fast64 zip file. When you got your model created, then you got to file export and export it to GLTF 2.0. Here's a very important thing. You got to make sure to check the include custom properties on GLTF export. If you don't have that checked, it won't work. I don't think I have a screenshot of that right there, but it's under like the export options. Then after you have your GLB file created, you copy it to the assets folder in your Pyrite project. It will automatically appear in the Pyrite64 files under assets. It's actually really quick. It's a lot quicker than Unity. You don't have to like wiggle your mouse or click off anything. It just automatically pops up. Then you go into scene, add object, add component, model static, model, select your GLB file. Here's some tutorial, some steps for making a Blender model for Pyrite64 right there. Got a link right there. One thing I ran into, it does crash a lot. At least for me it did. Maybe it's because I'm using the latest version of Blender, I don't know. But usually when it crashes, I had to go back and re-enable. I didn't have to reselect the Fast64 add-on, but I had to go back and select to re-enable it. Otherwise, it would be disabled. Here's another thing that I ran into. If things just aren't working, start over from a blank Blender project. I think I went down a wrong path the first time I tried this, and then I just started over, and then it worked. And then you got some options right here under your material. You want to uncheck the show simplified UI, and you'll have this combiner. So if you're doing a textured object, you want to have A set to primitive color, B set to 0, C set to shade color, and D set to 0. And that's just like the recommended starting point. If you know what you're doing, you can probably play around with these, but just to get something working, you want to pick that. Then you go under sources, then you select your material. And it is very picky about the material that you use. It's got to be really small. It's got to be like 32 pixels by 32 pixels. There is capabilities to do larger textures, but by default, it's got to be... I only got 32 by 32 working. If it's bigger than that, it just didn't work. Yeah, that's what I said right here. Must be small, 32 by 32. So I got that in another window. So I made kind of like a little sword, kind of like you might see in Zelda. Very simple model. I created this. Just started out with a little cube and then extruded the two sides right here. And then I extruded downward, then extruded upward, like where the blade of the sword was. And I extruded here, and then I just did a scale of 0 at the tip, and then merged those together. So that's my little simple sword here. You can see right here, one other thing I forgot to mention, you can select this Fast64 tab right here. Make sure your microcode is set to Tiny3D. Make sure that's also Tiny3D. And make sure your game under Fast64 global settings is set to Homebrew. This is kind of like what I was showing on the slide right here. Here's my material. You want to make sure you go in and select this Create Fast 3D material when you're doing this. Those are the only materials that will work. If there's already a material here, you can delete it with the little minus sign. I had problems trying to get more than one material on a single object. Never got that working. But here's like where I was talking about the ABCD, and here's the sources, and you just go in here and select. I got this texture wood small PNG file. You can play around with the settings right here, and this is where I mentioned like if it's too big, it will complain right here. So that's all you need to do, and then you go to File, then Export, and you want to use the GLTF right there. And this is my sword3.glb. Here's the options over here. Like I said, you want to include the custom properties, and like either selected or visible objects. You just do selected. I think all the other settings are usually pretty good. And then you export that to GLTF, and then you copy it over into your Pyrite64 project. So you need to go back into Pyrite64 and install it right here, or run it right here. Open a project. You want to go find your project. Okay, so here's the second project. This is one weird thing that I noticed about this is a lot of times by default it wouldn't show my models after I pulled them in. But you can click on it right there, and you can see here's where I set up the model, and I got the sword 2. You just click down like that. You can add the model. You just go to Add Component, and then go to Model Static. You can do animated models. I didn't get into that. So I already got Ares set up, so I can just do Build and Run. So there is a trick to actually get these to display. If I go into that demo project and then open this back up, then they should display. So yeah, here's like the simple like textured, a texture sword and an untextured sword. That was sword 2. Sword 3 is the texture sword, so it's got like this little wood texture that I downloaded. So that's kind of like the second step, just getting some models pulled into a project. Okay, this is what I just showed with the Pyrite, and I was using Gopher when I first did this. Okay, so talked a little bit about texture mapping. So here's another example I just did, like the Knox game design logo. Like I said, it's got to be really small. So I did this in GIMP, Knox game design. Kind of blurry, but you can kind of still, it looks like an N64 game. So once I had my Knox game design, then I exported that to a GLB model. Yeah, so here it is in Blender right here. This is my Knox box. I had to flip some of these faces around, but I just used like the standard UV, unwrap, cube projection right there. And then you can see over here, I didn't actually load the image in right here, but you can see like where it's texture map, just you can go into image, open. Yeah, so here's my assets. So in assets, I have the GLB file and the PNG file. Yeah, so here's like the 10 box right here in the Knox box. I was using the Knox box. So you can see right there where it's texture mapped out. Press tab like that. And as with the other ones, you can see if you go to textures, here's where it's using the fast 3D. Oh, it just crashed. Like I said, it will crash. Okay, so after you have this created right here in the GLB, then you come down here and you import it into Pyrite64 and you create your Z64 file. And then you can run it in your Ares emulator. And then after you get it running on your emulator, then you can put it on an actual cartridge and run it on real hardware. So next thing I want to do is I want to add a little bit of code to make this actually do something. So like I said earlier, scripts are in C++. I think you can also do C with like libdragon and tiny 3D. I'm not an expert on those, but if you're doing the Pyrite64, the Unity style environment, then I think you got to use C++. Bring your own editor. So you can use Notepad++, Visual Studio Code, VI, whatever you want to use. So the first thing I did is create a plain script, attached it to an object, verified that your game still builds and runs. Kind of like in Unity, you can add values to be exposed in the editor, and you do that by adding, I forget what this is called, but it's like 2 square brackets. You put it within 2 square brackets, then that will expose it in the editor, so you can assign those values, like this translate speed right here. That's where it's defined right there. So when you create a new object, you just go in right here under your scripts, and name your script, then it'll automatically put it down here and generate the C++ file for you. And it gives you a lot of starter functions such as init, story, update, draw, on event, and on collision. Very similar to Unity. So the first thing I did is in my update, add example code to translate and rotate an object. Be aware rotation is in radians. I think in Unity it's degrees, so 3.14 radians, which is pi, equals 180 degrees. So if you're working in degrees, you need to convert. And again, best way is learn by looking at the examples. Yeah, so this is the code. I was using Visual Studio Code. So I got this rotate object.cpp right there. Here's where I got those values right there. We can see them in the editor. So that's the first thing I did. I just rotated a box. So you got this constant expert, which I was amazed to find out there's still new releases of C++ that's still being like quote unquote developed. At least the specification is being developed for C++, and they're like on C++ 20 or something now. It's crazy. And it's got like some special like vector3 style data objects, fm_vec3_t. Got this value right here, variable rotation axis. So it's like a vector3, got it set to 0, 1, 0. Then you got FM quad rotate. That's how you rotate, and you specify the axis. And you got a delta time, just like in Unity. Multiply delta time by your rotate speed. And all your data for this object goes into this data. And then you got like the arrow notation, kind of like a pointer in C right there. So anything that you need to get from this object, you got to do data arrow. Then you can access it that way, the translate speed right there. Then you got FM quad norm right there. I guess it normalizes that vector. Then constant expression. So basically this creates kind of like a constant from an expression right here. And then here's where I have it. I'm modifying the position. So I'm translating this. So delta time times translate speed. Right there. Yeah, so here it is. Like I said earlier, if you already have like the example open, you can actually see the textures on these. It's kind of weird how that works. I don't know if that's a bug or if I'm doing something wrong, but that's how you get the textures to display. So yeah, here's like my sword object right here. See over here on the right side, I got the model static, and here's where those values have been exposed. So the one on the left, translate speed is 0, rotate speed is negative 6.28, which is negative 2 pi. So it will make 2 pi is one rotation. So it's going to do one negative rotation in 1 second. Click on the other sword. Rotate speed is 6.28. So it's going to do one positive rotation. I believe it's clockwise. Don't hold me to that. Translate speed 0, so it's not going to move. So then I got these two boxes, which are just like the static GLB. This one's going to translate 10, so it's going to go up in the Y direction, 10 units every second, which I believe the boxes are 64 units in size. It's going to rotate half a rotation every second. Then the bottom red one is going to translate, it's going to go down 10 units a second, and it's going to rotate the other way, 1/2 rotation every second. So let's go ahead and build, see if this will run. Yep, so here it is right here, our two swords. So yeah, the one on the right is rotating clockwise, the other one's rotating counterclockwise, and I got the two boxes that are going in the Y direction, one going positive Y, one going negative Y, and they're rotating. The swords are rotating faster than the boxes, so no control, really not a game. It just proves that you can get something moving and rotating. So that's kind of like the next step before you want to look at doing any sort of control or anything like that if you're new to this. So I mentioned a little bit earlier the API. So it uses two APIs, libdragon and tiny3D. I put like some links I don't know if this is the official documentation, but N64squid.com, homebrew libdragon. So this was really helpful right here because this like outlines all the joystick buttons and the sticks and the data structure for those. Then you got the joypad buttons over here and all the different values. I really didn't use Tiny 3D that much. I really didn't have to touch that. I know it was working behind the scenes. But if you need to know what those data structures are, this is a good resource right here. So the next step is actually kind of make a real game with collision. So what I did is I created this project, kind of like a space shooter, got enemies right here. So I'm going to have collision and prefabs. This is what it looks like over here when it's shooting. Go ahead and show this. This is the bullet collection with collision with the enemy. It doesn't check the collided object type, which is what you should do in a game, but I just want to get something working. So whenever anything collided with an enemy, then it's going to obj remove that enemy from the game. You can create prefabs. You just right click on an object and create the prefab. It'll inherit all the properties of the original object, and that's located. The actual prefab files are in the assets folder. So if you need to go in and delete one, you got to go into the assets folder to delete it. But this is what it looks like when you create the prefabs. I haven't figured out how to create a prefab at runtime, like with it instantiate. I haven't figured that out yet. I believe it's probably possible. I just don't know how to do it. Here's the shooting. So I have one bullet in the game. Pretty simple. This is how you actually get a reference to another object. So this is in the player object. I want to get a reference to the bullet and set the bullet position to the player position so the player can shoot it. You do this P64 object, then it's kind of like a pointer to the bullet. Scene manager, get current, get object by ID. So you got to make sure that ID number matches the ID of the object that you want to get a hold of. Then you can just do obj bullet, use your arrow notation, position X gets OBJ, which is the player, position X. And this is going to be like top down, looking down. So the kind of like the Y coordinate in 2D is actually Z. So object bullet position Z is going to get the player position Z. So yeah, this is what it looks like in Visual Studio Code. So here's the player right here. Player has a velocity X. Shoot cool. I never really got the shoot cooldown working. You got to make sure you put this in exposed, otherwise you won't see these in the editor. That's very important. It gives you this init delete. I didn't use it. Here's the update where you got two values here, held and joypad. Joypad get buttons held. Joypad get inputs. That gets the value of your joystick, whether joystick is the buttons are held and the direction joystick's held. Here's a speed for how fast the player is going to move. Here's another constant expr, vector 3, our horizontal direction. That's how we set the horizontal position using time, delta time, and the direction the joystick is pressed in the X direction. Then we got the same thing in the Z direction. Position gets direction of the joystick times time, delta time, times speed. This is where I was messing around with cooldown. Disabled that. This is where so I did get it where you can actually rotate your player, which really doesn't do anything, but it's kind of like a barrel roll. If you hold L or R, you actually rotate the player just to do it, just for looks. This code right here kind of binds you at the bottom portion of the screen, sets some bounds so you don't go off the screen. And here's where we're shooting. What I just said, if you joypad button A, then we're going to get, so there's only one bullet in the game, and just kind of keep moving it around. Whenever you press the shoot button, you move the bullet to the player, then it moves. So here's the bullet code right here. Bullet's pretty simple. Update right here. It's kind of moving between whether you do the input on the player or, so I really should get rid of that right there. That's when I was doing the input on the bullet itself, but it's better to do it on the player. Right here is like in the Z direction, we're moving -1 times time delta time times, like I say, in the default unit size is 64, so it's kind of like moving 20 units. 64 times 20 right there. And then if it gets past a certain point, we're just going to, so we're only going to move the bullet if it's within the viewable range. So that's what this check is right here. If it's greater than -1200, so the Z value actually decreases as we go up. And this is where we're moving the bullet right here. Position, add and assign, direction, delta time, times 64 times 20 right there. So pretty simple. I'm not using any of the other stuff. This is the on collision right here. So if it collides with anything, if it collides with an enemy, we're going to set the position to 1000 right there. So we're just going to move it off the screen. Really, we should have like an is alive Boolean type thing going on and doing that. But this is just a demo. And here's our enemies right here. So basically I have the enemies moving left and right. So they have a countdown, F countdown, max countdown. So the countdown set to 1, max countdown set to 2. So every 2 seconds it's going to change direction. It's got a speed, 64 times 5. So like I was saying, the default unit's kind of like 64. So we're going to multiply that by 5. So it's kind of going to move 5 units per second. Here's our update. Going to update the countdown, subtract off delta time. If countdown's less than 0, then we're going to change direction, data F speed, multiply and assign by -1. Then we're going to set the countdown back to the max countdown right there. And velocity, this is where we're moving. Object position, so we're only moving in the X direction, which is what we have set up right there, 100. So it's going to be velocity times delta time times data speed. So it's going to ping pong them back and forward. Here's our collision. If the bullet if anything collides with the enemy, then we're just going to remove the enemy. And there's no win condition. You just kind of got to watch when you destroy all the enemies, then it's over. So I'm going to go back to our pyrite, run it right here, open. Yeah, so here it is right here. I had to do all these prefabs by hand, which took a little bit of time, but the green ones are the enemies. I could have did models for these. I just ran out of time. It's in the end of March, end of the month, and I just wanted to get this done. Here's our bullet off to the side in the background right there. Here's our player, the cyan blue kind of box. Like I said, we got an enemy. Just go create prefab, then your prefabs are down here. Here's our enemy prefab, so you just got to drag these in one at a time. And then I had to manually set the position of all these, the countdown. I didn't have to change. Yeah, I had to set the position to all these right here. So I kind of started out with like 0, -256, and then I subtracted off 266, so 0, 512, -512, then 0, -768. So I kind of got these in 256 increments around. Here's something very important. You have to add the collision body component. So collision body right there, and it's kind of like Unity. You can do a box, or you can do. So since this is a prefab, I can't edit it, but you can go up to the top and edit the original right there. But you can either have like a box or a sphere collider, and you got to make sure that you got this mask read and mask write. It's kind of like layers in Unity, collision layers, and then you can set it as trigger so it doesn't respond to like physics or anything like that. So let's go ahead and build and run this guy. And here it is running in our N64 emulator. Like I said, we only have one bullet going at a time. So if I rapidly press A, then it's going to move that bullet back to the player's position because we only have one bullet. And like I said, there's no win condition, and the player's limited to this bottom portion of the screen right here. So these at the very end are kind of hard to shoot. right there. You kind of got to time it right. I just missed them right there. Oh, there I got them. Like I said, no win condition. But you could use this as a starting point to make a better game. So the only other one, and I kind of did these out of order. So I'm going to close, open, demo. So Project 5 was actually the boxes. Let's see if this works. So like I said, by default, a lot of times you can't see the boxes. But yeah, you can see here I got the Knox game design box and the Tennessee box, and then I have the camera right here behind them. So here's Knox game design. So here's how you attach code right here. You just add component code right there. Then you just pick the script. So I got Knox box CPP. Then I got one for the Tennessee box, 10 box CPP. So this is kind of like a nice little like starter project right here. Yeah, so Knox box CPP. All we're doing is like getting the joypad and the buttons and rotating. Right there, that's Knox box, file, open recent. And then 10 box. Same thing, but we're using the C buttons on the N64 controller right here. So let's go ahead and build and run. So this is what it looks like in the emulator. So I'm moving the Knox game design with this would be the stick on the N64, and then this one's the C buttons. So you can actually move those, and actually you can do L and R as well. So it rotates them, I think, on the Z axis or the Y axis. I can't remember. Okay, so here's the final step, getting it to run on real hardware. So I have a couple of options. I ordered these online. The first one I got was actually the one on the right, was the Everdrive64. So I got the X5. I think there's an X7 out, but it wasn't available. So I think this was kind of like an older model of the Everdrive, but it worked pretty good. It's from krikzz.com. I actually ordered it off another popular site. So you can get it from different places. But then there's another option called the Evergenesis 64, and that's by Kami-sama Games. They kind of do the same thing. I'm going to show a video of these. For the system, I used my original Nintendo 64 that I bought back in the 90s, created by Nintendo. You may be able to still find those at a used game store. I don't know. But there's also an analog 3D that I'm planning on getting one of these. It's from analog.co. The only reason I bring them up, I got the Analog Pocket Game Boy player, and I was really happy with that. So I'm thinking the analog 3D should be good, and the benefit of using it would be to play it on HDMI screens, which I think would be really cool. Yeah, so I recorded these on my phone earlier. So I'm just going to comment. So this is how the Everdrive came in a box and in the packaging and everything. This is what it looks like right there, kind of like an N64 cart. It's got the little hole on the side where you put in the micro USB. So there's I've been using this thing forever. It's my little, it reads anything, USB. This is me like putting the micro USB into my card reader right there. And that's what it looks like. Got a little hunt. So I did have to actually use my own USB, micro USB card with the Evergenesis. It actually came with its own, which is pretty nice. On all these, make sure you got the connectors going up. Don't do like I did, putting it in the other way. And it just snaps in there like that. Pretty simple stuff. So yeah, here's my other room where I got some of my game stuff. my original N64 right there, pop in the Everdrive, turn it on. One of my old monitors. So this is when I first tried it. So with the Everdrive64, you do have to download some files and move it over. So once you got those setup files copied over, you can put your Z64 file. So there you can see my different projects and the Knox game design first project that I did. And also I also moved over the jam example. But yeah, there's the very first step, the two boxes running on real N64 hardware right there. It's pretty nice. You can just press reset and it takes you back to the menu. Here's the second example, pulling in the Blender objects with the texture map working right there. Pretty cool. See it actually running on an N64. Here's the third project. So this is the spinning swords and the cubes, spinning cubes right there, running on the N64. On the Everdrive64, and yeah, just keep spinning. Spin, spin, spin. And here's the fourth project. Here's the shooter. This is like the earlier in the stages. So I do have like the different stages of development. So originally just started out with one player and one enemy. I have the code out there for all the different stages. This is me showing with the original N64 controller, moving the player around. Here's that example game jam game running on the N64 itself. Pretty cool. I noticed a couple of issues with the actual version running with like falling through the world on the second stage. It wasn't a big thing or anything, but I did notice small differences when running on actual hardware. That's it, running on the N64 right there. There's the controller, me walking around and jumping and everything. Yeah, it's got some really nice lighting effects, texture lighting effects. I haven't figured out how to do that yet. Okay, so here's the Evergenesis right here. The unboxing of the Evergenesis comes with the bubble wrap. Had a little bit of problem holding the camera and the phone and trying to open it up at the same time. But yeah, that's what it looks like right there. Pretty slick. You can see the battery. It's got a little LED light inside that lights up, I think, whenever it's like writing to disk or writing to its internal storage. And this is nice because it actually did come with a USB adapter. So you can put your micro USB into that, then plug it into your computer. And yeah, that's what the Summer Cart Evergenesis 64 looks like. Yeah, so this is what I was just talking about. You can put your micro USB right in like that, and then you just stick it in. It's kind of like the Everdrive. It's just got that little slot, and it just kind of snaps in like that to the Evergenesis. Now, the Evergenesis does have a USB-C slot on the other side, so I tried plugging in a USB-C into this and then plugged it into my computer, but unfortunately I wasn't able to copy over files that way. Like I said, I'm using Windows. Maybe it doesn't like Windows, I don't know. So yeah, didn't get that to work. And this is me copying over like one of the project files, project 5 Z64. You just copy it over. You probably want to make sure you do a proper eject. Here's me putting in the Summer Card, the Evergenesis right there. Like I said, it's got that little light inside whenever it has activity reading. But yeah, here's the first example again, the two boxes running on the Evergenesis Summer Cart. And here's the sword demo right there with the two swords. And so the Evergenesis actually comes with a lot of extra stuff on it. Here's the third demo with the two rotating blocks and the two textured swords right there. And the next demo is the little shooter. This is got the version with the prefabs added and the collision and all that good stuff, and didn't have the camera tilted high enough to see that top row. It's kind of hard to get that set up right there. But yeah, a little space shooter. Yeah, I really want to develop this further. I kind of want to take like the ideas I had from my SDL game, try to make a real N64 game. I think that'd be really cool. And here's the two boxes, the Knox game design box and the Tennessee box right there. Little rotation demo. This is me showing with the N64 controller, rotating Knox game design around, then the Tennessee with the C buttons right there. And hopefully I'll have the analog 64 3D soon. And I'll be able to test it out with that, but I probably won't have that in time for this podcast right here. So here's some links. Check these out if you want to, if you're interested for some more information. Community at N64 Brew, awesome N64 development, the main Pyrite 64 on GitHub, libdragon, Tiny3D, and Gopher64. All those links are there. So that's about it for March 2026 on N64 development. Want to remind everyone, we got the Knox Game Jam coming up. That's going to be next Friday. Yeah, so we got the Knox Game Jam coming up next Friday right there, 7 p.m. Eastern Time. It's actually UTC -4. Planning on meeting at Panera Bread on North Peters Road. So if anybody wants to come out and talk and chat, get to know everybody, we'll be doing that probably until they close and kick us out. But yeah, we do have on the main knoxgamedesign.org website, we've got some information about the game jam and how to submit your games and all that good stuff. So anyway, till next month, appreciate everyone out there listening and watching.